Um, Hello guys, welcome to my channel. Let us assume today we gonna solve another example, numerical example of SK Mapa real analysis book, chapter exercise 7 of chapter sequence. Okay, let's start the math. So first of all, we will solve using sandwich theorem to prove that number one and limit n tends to infinity root over n plus 1 minus root n is equal to 0. We have to prove this. And second math is limit using same using sandwich theorem. We have to prove limit n tends limit twice n plus 3 to the power n and whole 1 by n is equal to 3. Okay, so let's start. The first one, number one, we have to prove this. Let un is equal to so again un is equal to this. For the sandwich theorem, we have to find some vn or un such that at vn less than un less than wn and limit vn is equal to limit wn. So from sandwich theorem we can say that limit un also converges to the same limit. Okay, for this we know that n plus 1 is greater than n. Okay, for all n belongs to capital N, or n plus 1 to the power half is greater than n plus 1 to the power half, or root n plus 1 is greater than root n. ঠিক আছে, then root n plus 1 plus root n plus 1 is greater than root n plus root n plus 1. Okay, or 2 root n plus 1 is greater than the root n plus 1, or 1 by 2 root n plus 1 is less than 1 by root n plus root n plus 1. Okay, or this is un, so we have un is greater than 1 by 2 into root n plus 1 for all n belongs to capital N. So we will get the vn. Okay, so un is greater than 1 by 2 root n plus 1. Again we have root n plus 1 plus is greater than root n. If we add n plus 1 plus in both sides, so we will get 2 root n, or 1 by root n plus 1 plus root n is less than 1 by 2 root n. Okay, or this is un. Un is less than 1 by 2 root n. So for all n belongs to n. So we have, now we have combining these two inequalities, we can write 1 by 2 root n plus 1 is less than un, less than 1 by 2 root n for all n belongs to capital N. So from now again we have to check the limit of left hand side and right hand side. The left hand side of the limit is 0 and the right hand side is also 0. So from sandwich theorem we can say that limit un is equal to 0, that is limit root n plus 1 minus root n is equal to 0. Okay, if you have any question about this math, ask me in the comment section. I will try to answer it. Again, now we will start the second math. Here un is, let un is 2 to the power n root over 1 plus 1 by n. Okay, so we can write this taking 3n common. We can write 2 by 3n plus 1 whole to the power 1 by n. Okay, this is the un. Again we have 2 by 3 is greater than 0, that is 2 by 3 whole to the power n is also greater than 0, that is 2 by 3 whole to the power n plus 1 is also greater than 1, or 2 by 3 whole to the power n plus 1 to the power 1 by whole to the power 1 by n is also greater than 3, greater than 1, or 3 into 2 by 3 whole to the power n plus 1 is whole to the power 1 by n is greater than 3, or un is greater than 3 for all n belongs to capital N. Okay, no problem. Again, number 2, two is greater than 3, sorry, 2 is less than 3, or 2 is less than 3, or 2 to the power n is less than 3 to the power n. Okay, or 2 to the power n plus 3 to the power n is less than 2 into 3 to the power n. Okay, or 2 to the power n plus 3 to the power n whole to the power 1 by n is less than 2 to the power 1 by n into 3, or un is less than 2 to the power 1 by n into 3 for all n belongs to capital N. Okay, so we have 3 less than un less than 2 to the power 1 by n into 3 for all n belongs to capital N. So the left hand limit is clearly 3, and right from the right hand limit of the sequence is limit 2 to the power 1 by n into 3. This limit is 1 and this is 3, so this gonna be 3. Okay, so from the Sandwich theorem we have, from Sandwich theorem we have limit un is equal to 3. Okay, this will prove the math. Okay, if you have any question, ask me in the comment section, and if you are new in my channel, subscribe the channel and press the bell icon. Thank you.